Good day, students. Welcome to mathgoodserve.com. And this clip, we're going to be going over our algebra review on how to solve equations and inequalities. All right, let's take a look at question 1. It reads, Raimundo buys a smartphone on sale for $500 a week ago. He goes shopping today and buys another of the same smartphone for regular price. He pays a total of $1,150. Question: Write an equation for finding the regular price, and then solve the equation to find the regular price of the smartphone. Okay? Alright, so let's go ahead and start with the first part. Now we want to write an equation for finding the regular price. Okay, so we need to assign a variable to the one unknown in this equation, which is the regular price. So let's call that x. Okay, so let x be the regular price. Alright, so can we form an equation using x? We know that there are two phones and the total is $1,150. So if we want to set up an equation, we know that we have the following situation: the price of first phone plus the price of the second phone. The total means you're adding, okay? The total is equal to $1,150. The first phone was the one that had a discount, and the price of the first phone, what he bought a week ago, is $500. Okay, so the price of the first phone is 500. Now, what's the price of the second phone? The second phone that has the regular price without the discount. The price of the second phone without the discount is x. We declared that earlier. Okay, so 500 plus x gives us 1,150. So this is the equation that we can use to solve for the the regular price of the phone. Okay, so that's the answer to question 1a. Alright, now we're going to direct our attention to 1b. So this is 1a. Alright, so for 1b, we want to find the price, to find the regular price. Find the regular price. Alright, so basically finding the regular price just involves doing what? Finding the regular price involves solving for x. Okay? So let's go ahead and do that. We're going to start with the equation that we derived in part A of this problem, which is 500 plus x equals 1,150. So how do we get x by itself? To accomplish that, we have to undo this addition operation that exists here. So this is positive 500 being added to x, or x plus 500. So to undo this plus 500, imagine as though there is a visible plus here. Okay, so to undo that positive 500 on the left side, we're going to use the inverse operation, which is to subtract 500 from both sides of our equation. Okay, so go ahead and subtract that. And then you can just easily use your calculators to compute the difference between these two numbers right here. The difference is 650, but let's just do it with the calculator. 1150 minus 500, and you get $650. Okay, so what's the meaning of this answer that we got? This answer means that the regular price of the smartphone is what? The regular price of the smartphone is 650. Alright, let's take a look at question 2. In question 2, we're going to take a look at the graph of an inequality, okay? So for question 2, the question is as follows. Write the inequality that is represented by the graph below. Okay, so let's say we have the following inequality, something like this. And you have, let's say you have at point 3, you have an open circle, and it's going to the left. Now, can you write an inequality for this scenario right here? Well, we know that it's going to the left. We know that on the left side is less, all right, and on the right side is greater. Because if you put numbers on it, what happens to the numbers on the number line? On the number line, if you go to the left, it becomes 2. You know, it's getting smaller, and this is 4. It's getting greater, right? So since it's pointing to the left, we're going to be using the inequality less than. Remember, less than, L for less, okay, and left. For greater than, which is not the case here, it's going to be going in this direction. So this is the one we're using. Now it's also an open circle. It's going to the left and it's open. So we're going to be using this precise inequality right here. So it's going to be x is less than, because it's going to the left, and it stays just less than 3 because the inequality is open. Alright, so the answer is x is less than 3. And that, ladies and gentlemen, is your final answer. Alright, let's take a look at question number 3. So for question 3, we are to graph the inequality that represents the solution of the inequality below. So let's say you have the inequality 3x plus 7 as less than or equal to 28. So let's solve this. Okay, so our goal here is to solve and graph. Okay, so we have 3x plus 7 as less than or equal to 28. Now, how do you solve this inequality? You can solve this inequality with 2 steps. You subtract 7 from both sides, and then you divide by 3. That will result in the isolation of x, and that's the solved state that we desire. Okay? Alright, so let's get started. We're going to get rid of the 7 on the left first by using the inverse operation, which is to subtract 7 from both sides of the equation. And when we do that, that results in the inequality, not equation, that adds up to 0. So the inverse is we have 3x is less than 28 minus 7, 21. Now, to get x isolated, we said we'll divide before. The reason is because the relationship between 3 and x is a multiplicative relationship. The inverse of multiply is to divide, so we're going to divide both sides by 3. And that results in the final result. Divide both sides by 3. 3 goes into 3 ones. 3 divides 3 ones. And then we have x is less than or equal to 21 over 3 is 7. So the question is, do we switch the inequalities in this situation? Well, let's put a side point that you always want to keep in mind. when you are solving inequalities. Very, very important. So something to note. Note, you switch the inequality symbol when you switch the inequality when you multiply or divide by negative. When you multiply or divide by negative, you have to switch the inequality symbol. So in this particular case, we divided by a positive number, which is 3. That is why the inequality symbol remains the same. Alright, so there's no switch here. Alright, let's go ahead and graph it since we're asked to graph. So, what does that inequality there tell us? So we have less than or equal to, so it tells us two things. It tells us one is going to be going to the left, since it's less than, and then 2 is going to be closed circle. How do we know that it's going to be closed? Because there's a line underneath, which means equal, which means the boundary number is included in the solution set. Okay, so just graph 7, and you have a closed circle. What this means is 7 and any number, any real number to the left that's smaller than 7 on the number line will satisfy the inequality. Okay, so there goes the solution and the graph. Alright, let's take a look at the next problem, question 3. Now we're going to solve an inequality with variables on both sides. Okay, so instructions here are to solve the inequality. Solve the inequality. So let's say you have, I'm sorry, this is question number 4. Let's say you have the inequality 4x plus 5 is less than 6x plus 3. Okay. Alright, so let's go ahead and solve this. So to solve this inequality, we're going to try to collect all the like terms on the same side of the inequality. Alright, so we want all the x's. Let's put all the x's to the left, and then all the numbers to the right. So to move the 6x to the left, we use the inverse operation. This is positive 6x. So we're going to subtract 6x from both sides of the equation. Okay, so this 6x will go to the other side of the inequality. When we do that, what results? When we subtract 6x from both sides of the equation, 4 minus 6x will give us negative 2x. Okay, remember, when you have different signs, you subtract and keep the sign of the greater. Alright, so that's why it's negative, because 6 is bigger than 4. Negative 2x plus 5 is less than, those two add up to 0, less than 3. Now we have all the x's on the left side and they have been combined. Now we need to move the constants to the right, so our attention is now going to shift to the plus 5. Now what's the inverse of plus 5? The inverse of adding 5 is to subtract 5, so we go ahead and subtract 5 from both sides of the inequality, and then we're going to have that adds up to 0. We have negative 2x is less than 3 minus 5, subtract 2, keep the sign of the bigger negative. Okay, now to finish this off, we want to undo this negative 2 that's associated with this x. How do you undo multiplication? You use its inverse, right? The inverse, or the opposite of multiply, is to divide. So we divide both sides by negative 2, and we are left with x, instead of less than, x is greater than, minus over minus. When you divide negatives or divide the same sign, you end up with positive. Okay? So do you notice what happened with the inequality symbol? We switched the inequality symbol. Why? Remember we talked about this earlier. Whenever you divide or multiply by a negative, you have to switch the orientation of your inequality symbol. So that's why um, we switch the inequality symbol here. Okay, let's just put a side note. Um, Inequality switched. Why? Since we multiplied by negative. No, actually, we divided by. Yeah, since we divided by negative, that results in a switch of the inequality symbol. Alright, so there goes the final answer right there. Alright, let's take a look at another example. Now, this one is a simple or straightforward algebraic equation, but it assesses your ability to use a calculator. Alrighty, so let's say for number 5, you're asked to solve for the variable in the equation below. Okay, so let's say you have x over 3.2 is equal to 1.5. Alright? Alright, so let's go ahead and solve that. So the variable that we're looking for here is x. Okay, remember letters represent variables. So we want to get x isolated. Okay, so we have x over 3.2 is equal to 1.5. Now, how do we solve for x here? We need to get rid of this 3.2. The relationship is division. So what is the inverse of divide? The inverse of divide is to multiply. So what we're going to do is multiply both sides of the equation by 3.2 to undo this divided by 3.2 associated with the x on the left side of the equation. Okay? So what happens? On the left side, 3 goes into itself once, it goes into 3.2 once. And then we have x is equal to, now let's put this into our calculators. We want to compute the product of 1.5 and 3.2. 1.5 times 3.2 is 4.8. So that, ladies and gentlemen, is the value of the variable that satisfies the equation. Alright? So that's that. Alright, moving right along. Now let's go ahead and solve some equations that involve the use of the distributive property. So instructions are for us to solve the following. Equations. Alright, so we did number 5, so we're now in number 6. Alright, so for question 6, let's say we have the equation 24x plus 3 times 2x minus 2 is equal to 234. Alright, let's go ahead and solve this. Our solution is as follows. We have 24x plus 3 times 2x minus 2 is equal to 234. Now, when you see parentheses and multiple quantities inside, you're going to carry out a special type of multiplication known as distribution. Okay? So what we're going to do is we're going to take positive 3 and we're going to distribute it to the terms in the parentheses. Okay? We're going to multiply. That's what the distributive property is. You're multiplying the number in front of the parentheses by everything in the parentheses. Okay? So if we do that, we're going to have 24x plus 3 times 2 is 6x plus 6x, and then 3 times negative 2 is going to be negative 6. Remember, when you multiply different signs, you always end up with minus. That equals 234. Now let's go ahead and combine like terms. 24x plus 6x can be combined together, and that yields 30x. You have 30x minus 6 equals 234. Okay, as a result of combining these two right here. Okay, and then we need to finish this off. We need to get 6 to the right side and get rid of 30. To accomplish that, what we're going to do is add 6 to both sides and divide by 30. Okay, let's proceed. Add 6 to both sides of your equation. When we do that, we have, what do we have? We have, or this adds up to 0 since they're opposite. 30x is equal to 240. Now to get x isolated, we just divide both sides of the equation by 30. And your final answer, x, will be, you can divide that by hand or with your calculator. The zeros divide out, 3 goes into 24 8 times. And that's the solution to question number 6 equation. Alright, let's take a look at one more problem in this review series. Still working on the distributive property. So let's say we are to solve the equation 14x minus 7 times 9x plus 23 is equal to 770. Okay, so let's go ahead and do this. Now we have 14x minus 7 times 9x plus 23 equals 70. So when you have a parenthesis and a number in front with multiple terms in the parentheses, you're going to distribute, right? So what we're going to do is distribute negative 7 to both terms in the parentheses. Now what you want to keep in mind is when you multiply, when you distribute a negative sign, the signs flip. Okay, so let's put a side note there. Note. When you distribute a negative sign, the sign flip. Remember, minus can be thought of as opposite. Alright, so when you distribute opposite, what's going to happen is that every term you distribute that negative 2 becomes an opposite sign of the sign that it had before. Okay? So that's the effect of distributing negative. So we're not just distributing the 7, we're distributing negative 7. So keep that in mind. So what does that yield? We have 14x, bring down 14x. Negative 7 times positive 9x results in, see, the sign becomes negative 63x. Negative 7 times positive 23. 7 times 20 is 140. When you add 7 times 3, which is 21 to that, you get 161. What is minus times positive? Remember, when you're multiplying different signs, you always end up with the difference, negative. 7 times 23, 161, equals 70. Now, as we did in the previous step, we can combine like terms wherever possible. So 14x minus 63x. We subtract and keep the sign of the bigger, so we can just subtract these two. You get 49x. Since the bigger is negative, you have a negative there. Negative 49x minus 161 equals 70. And then we're going to proceed to get x isolated. This can be accomplished in 2 steps. You get rid of this 161 by using the inverse. You add 161. And this is being multiplied by x, so we divide by 49, negative 49, sorry, to get x by itself. Alright, let's carry out the process. We add 161 to both sides. First, as though you're doing PEMDAS backwards, you add and subtract before you multiply and divide in the process of solving the equation. So this side right here, they add up to 0. So that yields negative 49x, is equal to 70 plus 160 plus 161. So 70 plus 161 is positive 231. We have 231. And then to get x by itself, we're going to proceed to divide both sides of the equation by negative 49. Okay. And that gives us the final result, which is x is equal to 231 over negative 231 over 49. So you can reduce this by hand, or you can use a calculator. Let me show you a neat little calculator trick you can use here. So we want to see the simplified form of 231, negative 231 over 49. You might be able to simplify it, you might not. We don't know yet. So what you do is you divide it like this, and you have the decimal equivalent. Now, if you want to um, see what the fractional equivalent is, if it's the same as this or a simplified form, what you do is you enter what you want to compute the quotient or divide. Negative 231 divided by 49, and then you press math button, and then you see arrow fraction means convert to fractions. Okay, press enter. So negative 231 divided by 49, we're going to convert it to fractions. Now if this is irreducible, it will return the same answer as we gave in as we put here. But if it's reducible, it will give us the reduced form. Okay, so press enter. What do you get? We get negative 33 over 7. So this basically helps us to see that 7 goes into 231. Okay, 231 divided by 7 should be what? Should be 33. Okay, so if we were doing this by hand, what we'll have done is we'll just simply divide the top and bottom by 7. But that requires that you know that 231 is divisible by 7. But if you don't know and you can use a calculator, which you can use on the test, you just use a calculator trick and you end up with negative 33 divided by 7 as your final answer. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of equations and inequalities, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, or you want any special algebra tutorials for us to make for you, just post your requests in the comment section below, and we'll be more than glad to assist. Don't forget to subscribe to our channel for updates to other tutorials such as this. More videos, worksheets, games, and support tools can be found at mathgetserved.com. Go ahead and check it out. And if you would like to gain access to the entire playlist, you can just scan this QR code or just go to our YouTube page. Thanks again for watching, and have a wonderful day. Goodbye.